Right, today in geometry, we are looking at section 10.2, which is all about arc measures. So we're going to start out with some vocabulary. So first, a central angle. So a central angle of a circle is an angle whose vertex is the center of the circle. An arc is a part of a circle. A minor arc is a part of a circle that measures less than 180 degrees. A major arc is a part of a circle that measures between 180 degrees and 360 degrees. And then a semicircle is an arc with endpoints that are endpoints of the diameter. Now we're going to talk about how do we name arcs. So minor arcs are named by their endpoints. Major arcs and semicircles are named by their endpoints and a point on the arc. So a minor arc generally is named with 2 letters. So here, the arc between M and I is a minor arc. So I would say MI, and then the notation for arc is like a little arc symbol above it. The major arc, again, what we see in yellow, so MNI, so MNI, and then an arc above it. And again, usually, okay, your major arc is going to be named with 3 letters. And then the semicircle, okay, so the semicircle, we see that the yellow part up here, but I don't have another name right here. So let's see if I called that B. Then I would say DBM. So arc DBM would be my semicircle. All right, so now let's review a chord. Recall that a chord is any segment with endpoints on the circle. Any chord divides the circle into 2 arcs. A diameter divides the circle into 2 semicircles. Any other chord will divide the circle into a major arc and a minor arc. So in this picture, my diameter is segment LE. Minor arc would be arc IE. My major arc would be arc, let's see if I started here, I could go ELI, so arc ELI, and then my semicircle, arc LIE. Now we're going to talk about how do we measure arcs. The measure of a minor arc is the measure of its central angle. So that's nice. You know your central angle, you know the measure of your minor arc. The measure of a major arc is 360 minus the measure of the minor arc. In a circle, we have 360 degrees. So if I have a major arc and a minor arc, 360 minus the minor arc gets me the major. The measure of a semicircle is half of 360, so 180 degrees every single time. So now we're going to work some problems. Okay, now we know everything to work this problem. Okay. So it says circle N with measure of angle ONE is 35 degrees. So they're giving me that central angle because the center is N and my center is the middle, the vertex of that angle. So this is a central angle 35 degrees. They want me to find the measure of arc OE, arc OPE, and arc POE. Okay, so OE, that is this minor arc right here. Minor arc is the same as central angle. Central angle is 35, so that's 35. So the measure of arc OE is 35 degrees. The measure of arc OPE, so OPE, that's what's left. So the measure of arc OPE is going to be 360 minus 35. So that's going to be 325 degrees. And finally, the measure of arc POE POE, that's a semicircle, so I automatically know that's 180 degrees because it is a semicircle. Okay, so let's flip it over, work another problem. So they give me this picture. They tell me that the measured angle IPE is 45. Again, that is a central angle. So arc IE, I automatically know is 45 degrees because it is the same as my central angle. Measure of arc LE, okay, LE, all the way around here, that's a semicircle, so it's 180 degrees. Measure of arc LI, well, LI, I know that LIE is a semicircle, 180, so if I do 180 minus that 45, that's going to get me the LI, so that's 135 degrees. And now the measure of angle LPI. So I want this angle in here. I just found this arc to be 135, so that central angle has to be the same thing as that arc, 135 degrees. So now let's get some more vocab and learn some more rules. Two arcs of the same circle are adjacent if they have a common endpoint. You can add the measures of adjacent arcs. So we have an arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So here it says the measure of arc ABC, so ABC all the way around, is equal to the measure of arc AB plus the measure of arc BC. So it's just like our segment addition postulate or angle addition postulate, the arc addition postulate. Add the two small parts together, I get the big parts. Two circles are congruent if and only if they have the same radius. Two arcs are congruent if they have the same measure and they are arcs of the same circle or of congruent circles. So if circle C is congruent to circle D, then I can write circle C congruent to circle D. Bisecting arcs. Remember, bisect means cuts in half. If arc XY is congruent to arc YZ, down here in this picture, then the point Y and any line, segment, or ray that contains Y bisects arc XYZ. And then we put those tick marks there. Okay. So now let's work some problems. So this first one, identify the given arc as a major arc, minor arc, or semicircle, and then find the measure of the arc. So the very first one, arc TQ. Well, the measure of it is 120. So that is a minor arc, 120 degrees. Remember, minor arc is less than 180. Arc QRT, so QRT. So all the way around, I see that's going to be a major arc because that's more than a semicircle. Let's see, I know the entire thing is 360, so if I did 360 minus 120, I'm going to get 240 degrees there. Arc TQR, well, that's a semicircle. So I know that's 180 degrees. Arc QS, so it's arc QR plus RS. So I need to find RS. I know all together has to be 360. So 360 minus 60 minus 120 minus 80 leaves me with 100. So arc QS is going to be 100 plus 60. So that's a minor arc, 160 degrees. Arc TS, again, it's minor, 80 degrees. Arc RST, another semicircle, 180 degrees. Okay, so we're going to go directly across over here now. It says tell whether the segment is best described as a radius, a chord, or a diameter of circle C. So this is a review of the very first day of chapter 10, right? So segment DC, that's a radius. Segment BD, that's the special chord that goes through the center, so that's the diameter. Segment DE, that's simply a chord. Segment AE is another chord. Right, so let's go to our next piece. Okay. So it says the survey. A recent survey asked teenagers if they would rather meet a famous musician, athlete, actor, inventor, or other person. The results are shown in the circle graph. Find the indicated arc measures. So A, the measure of arc AC. So A to C, so I need to add 29 plus 108. That's what we're doing here. 29 plus 108. So that gets me 137 degrees. B, the measure of arc ACD. So ACD, so I know A to C was 137, so here I'm just doing 137 plus 83, and I get 220 degrees. C, the measure of arc ADC. So now I'm going this way, so I'm going to erase what I have there. So ADC, I'm going this way. So I'm going to add up these three numbers. So 79 plus 61 plus 83 is 223. Now the measure of arc EBD, so EBD. So let's see. EBD is everything except 61. So I could do 360 minus 61 because the entire circle is 360. So I'm going to get 299 degrees. All right, we're going to go directly across over here. Another survey. A result of a survey about the ages of people in a town are shown. Find the indicated arc measures. So again, A, the measure of arc RU. So R to U, I'm going to do 60 plus 80, right? So this is 60 plus 80 equals 140 degrees. B, the measure of arc RST. Okay, so now I'm going this way, RS to T. So this is 100, this is 30. So I'm adding those together, so 130 degrees. The measure of arc RVT. So RVT all the way around. So it's including everything except the 130. So I could do 360 minus 130 to get that, which is 230 degrees. Or I could have just added up 60 plus 80 plus 90. And finally, the measure of UST. So UST, so that includes everything except 90. So I could do 360 minus 90, so that's going to be 270 degrees. All right, so now it says, tell whether the red arcs are congruent. Explain why or why not. So here I have this arc and this arc. This is 80 degrees, this is 80 degrees. All right, so we're going to determine if arc CD is congruent to arc EF. In order for them to be congruent, the circles have to be congruent. These are both in the same circle, so obviously our circles are congruent. I have an 80 degree and an 80 degree, so this is going to give me 80 and this is 80. So I could say that arc CD is congruent to arc EF because in the same circle, and the measure of arc CD equals the measure of arc EF. So now B, I'm looking at arc SR and arc UT, okay? They are both 90 degrees, right? So I know that the measure of arc RS equals the measure of arc TU, but are they congruent? Okay, but they are not congruent. So they are not congruent because the circles are not congruent. They don't have the same radius, right? Remember that for our circles to be congruent, they have to have the same radius. So the small circle, this is my radius. The big circle, this is my radius. So obviously the circles are not congruent. If the circles are not congruent, then the arcs cannot be congruent. So they're not congruent. And C, I see that my circles are congruent. Okay, so I see that my circles are congruent because the radiuses are the same. Both my radiuses are marked with one tick mark. So then this is 95 and this is 95. So the measure of arc Vx equals the measure of arc Yz. And since the circles are congruent, therefore arc Vx is congruent to arc Yz. Okay. So we're going to do some more of that. So 7 and 8 down here, tell whether the red arcs are congruent. Again, are my two circles congruent? Okay, so yes, okay. Arc AB is congruent to arc CD because the circles are congruent, because they have the same radius, right? The radiuses are marked congruent. I know that the measure of arc AB is equal to the measure of arc CD. They're both 145 degrees. And since the circles are congruent, that means the arcs are congruent. All right, so now over here, I see that they're both 120, right? So the measure of arc MN equals the measure of arc PQ. But they're not congruent because my circles are not congruent. I notice that they don't have the same radius, right? Not the same radius. So in this circle, my radius is 5. In this circle, my radius is 4. So they're not the same radius, so the circles cannot be congruent. Therefore, my arcs cannot be congruent. All right, that wraps up section 10.2, arc measures. Tomorrow we will look at 10.3, which is chords.